Hey guys, it's Mr. Brengle, and today I'm going to be going over the FPM Pre Quiz in preparation for our real quiz. This problem states that a flower pot weighs 22 newtons and it's hung above a window by 4 ropes, each making an angle of 12 degrees with the vertical, as shown by me here in a second. What is the tension in each rope supporting the flower pot? So let's just draw a little diagram here. Here's our flower pot, and there are 4 ropes that are connected something like this, okay? And so we want to draw a force diagram of that, but it's going to be a little busy because we've got Fg, the weight of the flower pot, and then there's going to be all of these forces, Ft1, Ft2, Ft3, and Ft4 that are all pulling. And we don't want to mess with that. We would rather just look at one rope. So instead of drawing it like this, let's redraw it with just one of those ropes. This is Fg right here. And then we'll just go like this, and we'll label this 4Ft instead of just 1Ft, because all of the ropes make the same angle with the vertical. So now we can make our triangle here, and then we can label these sides. This is the angle with the vertical up here, and that's equal to 12 degrees. And then we're going to want to label our sides. So this would be the adjacent side would be the vertical side. So this would then become whatever's on the hypotenuse, 4Ft cosine theta, because we're on the adjacent side. And then down here on the x-axis is going to be 4Ft sine theta, because we're on the opposite side. So now we need to figure out what's the tension in the rope. Let's do a sum of the forces in the y direction, because it has given us a value in the y direction, which is the weight of the flower pot at 22 newtons. So we'll do a sum of the forces in the y direction is equal to 0. So we'll take whatever is pointed up, whatever's above the x-axis, which would be 4Ft cosine theta, that's pointed up, minus Fg, because that is pointed down, is equal to 0. We'll then rearrange, so I'm going to add Fg to the other side. And then we need to divide by 4 cosine theta to get Ft by itself. So Ft is equal to Fg divided by 4 cosine theta. Okay, now we'll just plug those values in. 22 newtons divided by 4 times cosine of 12. You should get a tension force equal to 5.62 newtons. Now, if you had not included the 4 over here on these things, if the 4 wasn't there, you would basically just be solving for the total tension of the 4 ropes combined, and then you would need to divide it by 4 at the end. Let's move on to the next problem. All right, so a box is placed on an incline with an angle of 42 degrees, so that would be the angle down here. Box has a mass of 24 kilograms, so that means that the weight of the box is going to be 24 times 10, which is 240 newtons. It wants to know what the normal force on the box is, the type of friction holding the box on the place or in place, and the value of the force of friction. So, as always, we're going to start with our force diagram here. So I'm going to draw my dotted line at an angle, because that's now my x-axis. And then we'll say this is our center of gravity. We know that the normal force points straight up on the y-axis, so we will need this to be perpendicular here. If you go ahead and draw that dotted line, that will help us later. So we'll label this the y-axis. Okay, so we know that the normal force is perpendicular to the surface, Fg is pointed straight down, and the frictional force would be pointed back along the x-axis. So if we're trying to figure out which force we need to make the triangle with, we want to do that with the force that is not on the x or the y axis. In this case, that is the force due to gravity. So we'll make a triangle there. And we need to make a right angle between FG and the y axis. So we're going to make our triangle like this. And this is a right angle right here. And the reason that we need that is because this force right here, Fg, the weight of the box, is not all pointed straight down. It's broken into two components. It's broken down into the y component and the x component. And what this is saying is that part of this force right here is going straight down, and the other force is pulling down along the x-axis. So this line right here has to be parallel to this line because this is the force that opposes the force due to friction. What we're going to prove here in a second is that Fn, that Fn right here is equal to the y component of Fg, and that the force due to friction is equal to the x component down here. So let's start off and solve for the normal force. So to do that, we're going to need to do a sum of the forces in the y direction. It's equal to 0, and we're going to need to label our sides. So remember that this angle here is going to be 42 degrees, and we went over how to get that in class. And then this is going to be Fg cosine theta, and then down here this is going to be Fg sine theta. So Fn, which is pointed up, minus Fg cosine theta, which is pointed straight down on the y-axis, is equal to 0. Fn is equal to Fg cosine theta. And now we can plug our numbers in. So we know that the weight is 240 newtons times cosine of 42. And this is going to give us a normal force equal to 178.35 newtons. So there's part A. For part B, it wants to know what type of friction holds the box on the hill. Since the box is not moving and there is a force that is pulling it down, Fg sine theta, that means that it is static friction. So I'm just going to put static right here, static for B. Now it wants to know what is the value of friction holding the box on the hill. And to solve for that, we're going to need to do a sum of the forces in the x direction and set that equal to 0 because the force of friction is on our x-axis. So the force of friction minus Fg sine theta is equal to 0. Add Fg sine theta to the other side and prove that they are equal to each other. And then we can plug our numerical values in. 240 newtons times sine of 42. This is going to give you a force of friction that is equal to 160.59 newtons. All right, let's move on to number 3. All right, so on number 3, first thing, let's go ahead and look at this diagram to the right and just mark out this 5,480 newtons. That's just from our homework assignment. I just used the diagram here, but we're going to use different numbers. So it says a 12,400 Newton wrecking ball is pulled back so that the rope makes an angle of 32 degrees with the vertical. What is the tension in the rope? What force was the ball pulled back with? So let's draw our force diagram here. We know that we have FG pointed straight down. We know that the ball is being pulled to the right with the pull force, F pull. And we've got this angled force right here that we're going to call the tension force. So the only value that is not on the x or the y axis, which would be straight up and down for the y and left to right for the x, would be the force due to tension. So we are going to make our triangle with the tension force. And our angle is 32 degrees to the vertical, so that means that that's this angle right here. So since the y-axis is adjacent to the angle, we're going to label this side ft cosine theta, and we'll label the x-axis ft sine theta since it is opposite the angle of interest here. Now we want to solve for the sum of the forces in the y direction to get the tension in the rope. Because we know that Fg is equal to 12,400 newtons. So we have to use that value, and that's in the y direction. So the sum of the forces in the y direction is equal to 0. Whatever's pointed up, which in this case would be Ft cosine theta, minus Fg, which is pointed down, and that's equal to 0. So let's get Fg off of this side here. Ft cosine theta is equal to Fg. And then we'll divide by cosine theta to get Ft by itself. So the tension force is equal to the weight of the wrecking ball divided by cosine of theta. Let's go ahead and plug our values in here. So it's going to be 12,400 divided by cosine of 32. This is going to give you a tension force of 14,621.81 newtons. All right, and then it wants to know what is the pull force, and that's in the x direction. And if you had tried to do this first, you would not have been able to solve for it because, as you're about to see, F pull, which is going to the right, minus Ft sine theta, which is going to the left, is equal to 0. And we can't solve this without the tension force. So we have to solve for the sum of the forces in the y direction in order to get the tension force, and then we can plug it in for the pull force. So F pull is equal to Ft sine theta when we add it on each side. And now this is where we can plug in our 14,621.81 times sine of 32. This is going to give you a force of 7,748.38 newtons. And we'll finish up with problem 4. Okay, so a 50 kilogram skier takes to the slopes and reaches a constant velocity, which is key because that tells us that the forces are balanced in the x direction. Find the skier's normal force and the force of friction keeping him from accelerating down the hill. So once again, we've got an incline problem. So we need to show that with our force diagram. Draw your dotted line, which represents the x-axis, and then we'll perpendicular to that is our y-axis. We know that FG points straight down, always, And we know that the normal force is perpendicular to the surface, and that the frictional force acts in the opposite direction of movement. So once again, the only force that is not on one of these axes is Fg, so we want to make our triangle with Fg and the y-axis. We want a right angle right there because, again, we need this line to be parallel to this line so that it can balance out the frictional force. So it tells us in the problem over here on the side that there's a 35-degree angle, and that means that it's also going to be 35 degrees up here. We are going to label the y-axis, the adjacent side, as Fg cosine theta. And we will label the opposite side Fg sine theta. So the first thing, we'll go ahead and solve for the normal force, which is in the y direction. So sum of the forces in the y direction is equal to 0. Fn is pointed up minus Fg cosine theta, which is pointed down, is equal to 0. Normal force is equal to Fg cosine theta. Normal force is equal to, the mass of the skier is 50 kilograms, so that means that the weight is 500 newtons times cosine of 35 degrees. You find that the normal force is equal to 409.58 newtons. The next step here would be to find the force of friction, and since friction is acting in the x direction, we will go ahead and do a sum of the forces in the x direction. We know that's equal to 0 because he's moving at a constant velocity. So, force of friction, just going to the right, minus Fg sine theta, which is going to the left. It's on the left side of the y-axis. This is equal to 0. So, force of friction is equal to Fg sine theta. And now we can plug our values in. 500 times sine of 35. This will give you a force of friction equal to 286.79 newtons.